In this video, we're going to take a look at conditional probability. That is the probability of A given B is, and our notation is P of A vertical bar B. So again, this means the probability of A given B is equal to the probability of A and B divided by the probability of B. And this is how we determine something of this form. Let's go ahead and take a look at an example. So we have a data set that we used in the couple of recent videos. So we have a bought TV, bought computer, yes, no, total, yes, no, total. And this data set said that we surveyed 400 people at a local store, and we had 75 of those 400 bought both a computer and a TV, 150 bought a computer but not a TV, and so on down this list. All right, so that was our filled in data set. And suppose this is our information or our data set that we have, and we want to ask the question. Well, first, let A be bought a TV. So A is the event bought a TV, and B is the event bought a computer. And we want to determine probability of A given B. Well, what should that be? Let's just think about what that means before we use the formula. This should be, well, let's suppose, right? Probability of A given B means we are supposing that the person bought a computer. So we reduce our data set to only the people who bought a computer. So if we look at that data set, that is just 225 total people. So the probability of A given B, the probability that somebody bought a TV given that they bought a computer, means that we only look at the people who bought a computer. Then of those, how many bought a TV? Well, that was 75 out of 225. Or in other words, 1/3. So let's use our formula now. Probability of A given B is probability of A and B over the probability of B. This is 75 over 400 all over 225 over 400, which of course reduces to 75 over 225, which is 1/3. So we see that this is in fact how we make this calculation of probability of A given some condition or event B. Now there's something related to this called a decision tree, and I want to draw that on this next page. So let's take a look at this. So we have what is called a decision tree, and I will define how to draw this now. So over here on the left, we have all shoppers. And then for each of our variables, so one of those variables was, did somebody purchase a TV or not? We separate our tree. So perhaps here we put purchased TV, and here we did not purchase TV. So this is the probability of A. If we call A purchasing a TV, which was 200 out of 400. And the probability of not A, so A complement, which was also 200 out of 400. Just looking back at your data set. But then, each of those, within each of those data sets, we can ask we can break it up based on the other variable. So here we had bought a computer. I'm just going to do COMP to represent bought a computer and not computer. All right, and then we have the same breakdown over for the bottom part here. And what is this? This right here is the probability of A and B. So the probability that we purchased a TV and a computer. That total probability is 75 out of 400. Here's the probability of A, that we purchased a TV, and not a computer, so B prime. That was 125 out of 400. And then probability of A prime and B. This is did not purchase a TV, but did purchase a computer. 150 out of 400. And this is probability of A prime and B prime, which is 50 out of 400. And what this decision tree does is it just gives you a list of all possible outcomes at the end, and you can just read along the paths to tell you which outcome you are referencing. So again, here, if we want purchase a TV and not a computer, we just run along this path, and this will tell us what that probability is. Notice that, of course, all of these sum to be 400 over 400, which is equal to 1. So we should get all of our probabilities summing to 1 over here. And within each part, the probabilities here should sum to the probability that a TV was purchased. That happens to be 50% here, but that's not always going to happen. This doesn't have to be the same as the probability here. It just happened in this case because purchase a TV was 50% and not purchase a TV was 50%. And this is how we draw a decision tree. And that's actually where we'll end this video.